Okay, today in class we talked about writing equations of a line. So there are various different ways we're going to look at this. We're going to write an equation given slope and intercept. We're going to write the equation of a line passing through a point with a given slope. We're going to write an equation of a line passing through 2 points, and finally we'll write an equation of a line that's either parallel or perpendicular to a given line. So just as a review, slope-intercept form is y equals mx plus b, where m represents your slope and b represents your y-intercept. So our first example says write the equation of a line in slope-intercept form with the given slope and the y-intercept. This is where we just get to fill in. Y equals our m, negative 5 over 2x, plus b, here it's minus 8, or you could say plus negative 8. Another way that we will write the y-intercept, we can say that it passes through the point 0, 10. So if it passes through the point 0, 10, 10 is your intercept that you will put in place of the b. Okay, point slope formula, y minus y1 equals m times x minus x1. I did show my students that if we wanted to isolate m, that means get it all by itself, then we would get rid of this piece. Because they're attached by multiplication, we would divide. And then I said, what does this look like? And they said, hey, it does look like our slope formula. And I said, that's because it is. So anyway, that's where our slope formula comes from. It does come from this point slope formula. So within our point slope formula, the m represents our slope, and the x1, y1 is the point that will be given to us. So here it says write an equation in slope-intercept form for the line that passes through the given point and that has the given slope and passes through the given point. So we're going to use that point slope formula because we have a point and we have a slope, and then we're going to fill in things. In the point slope formula, there are two values that never get replaced: the y and the x. They must remain in the equation. So it does read y minus y1. Our y1 is that negative 2, so it's minus a negative 2. Our slope is negative 5. And then x minus x1, which is 4. From here you have two steps. You have to distribute your slope through, and I'm going to go ahead and change this to a plus 2 because we have two negatives. And we get negative 5x, and then negative 5 times negative 4 is positive 20. From here we subtract 2. That's your last step, and you get negative 5x plus 18. Whoops. So on example 2, same idea. We do not replace the y or the x, but everything else gets replaced. So our y1 is a 6. Our x1 is a negative 2, so it becomes positive 2. And our slope is 2/3. From here you have two steps. Distribute is your first. So we get y minus 6 equals 2/3 x plus 2 times 2 is 4/3. And we want to add the 6. And I said, hey, is it okay for us to do 6 and 4/3? And we decided that we couldn't have a mixed improper fraction. So we either need to convert the 4/3 to 1 1/3 and add those to get 7 1/3, or convert the 6 so that erase that. We have a common denominator, so we would be adding thirds, so 3 times 6 is 18, and 4/3 plus 18/3 would give us 22/3. Either form I will accept. I'll either accept mixed or the improper. Example 3, we have 2 points that it is passing through, but we are missing slope, so we're going to use those two values to find slope. Remember, slope is your change in y over your change in x. So negative 2 minus a negative 8 or plus 8. And then our change in x, 4 minus 3. And this gives us 6 over 1, which is just 6. And then we're going to use that information to fill in our formula. and at this point you need to determine which point you're going to use. I'll go ahead and use the first one. It really doesn't matter. So it's y minus a negative 2, it becomes plus 2. Our slope is 6, and x minus 4. Again, you have this 2 steps. Distribute the 6, and then from here you'll subtract the 2 from both sides to get 6x minus 26. So again, we're given 2 points. We don't have a slope, so you're going to find slope by using the slope formula. So we're going to do 3 minus 0 over 1 minus 5, which gives us 3 over negative 4. And that negative, it doesn't matter if it goes to the 3, to the 4, or to the middle of your fraction, as long as it doesn't go to both. And then we'll fill in our point slope. So from here, I'm going to go ahead and choose to use the first point. So y minus 3 and x minus 1, and then our slope is negative 3/4. From there, distribute your slope through. You get negative 3/4 x, and a negative times a negative is a positive 3/4. And then from here, we add 3 to both sides. So we get y equals negative 3/4 x plus 3 and 3/4. Alright, this example asks us to write the slope-intercept form of an equation of a line that passes through the given point and is parallel. So because it's parallel, we know that these are 2 lines that never intersect and they have the same slope. So you're going to look at the equation that is given and identify the slope. Here we can see that the slope is negative 3, so we're going to use that slope and that point. And I do like to stay with that point slope formula. I know that you can use slope intercept and find b, and I did show my class that, but I think it's just as easy to use point slope. So we're going to fill in what we know. We know that y1 is 5, x1 is 3, and our slope is negative 3. From here we distribute the negative 3 to both terms, and then add 5. We get y equals negative 3x plus 14. Okay, again, we're looking for a line that's parallel, so we're going to take this equation because we need to find slope. To find slope, you have to have y isolated. So we're going to move 5x to the other side. And this enables us to identify that slope. So our slope, because they're parallel, we're going to use exactly the same slope. And our slope is negative 5. Then from here, we're going to fill in what we know into the point slope form. So we do know that y1 is negative 1, so it becomes plus 1. Our slope is negative 5, and it's x minus 2 from that point up here. From there, you'll distribute the negative 5, so you get negative 5x. Negative 5 times negative 2 gives you 10, and then subtract 1 to get y all by itself. Okay, 5 is slightly different. It's the same idea. We're given a point, it's going to pass through it, but now it has to be perpendicular. Now to remember what it means to be perpendicular, these are slopes that have opposite or negative reciprocal slopes. So here is the slope of this line, but we don't want that slope, we want the slope perpendicular. So I always do this, I write slope perpendicular. Remember, we have to flip it and change the sign, so the slope perpendicular will be 3. Now we're going to use that slope and our point here to write the equation. Okay, so we're going to fill in y minus 5 from the y1 from our point, x minus 3, and then our slope actually is also 3. So we distribute these through, we get 3x minus 9 on this side, y minus 5 over here. To isolate the y, we add 5. And we're left with y equals 3x minus 4. Okay, 10, same idea, except that we also have to get y by itself in our first equation. So to get y by itself, we're going to subtract the 5x. And we did this on a previous example. However, we do not want the same slope. We want a slope that is perpendicular to this line. So we have to flip negative 5 and then change the sign. So it'll become positive and our slope will be 1/5. We use that in our point that was given, and we're going to fill in this equation. So we'll go ahead and say that our y1 here is this -1, so we have a minus a negative, so it becomes plus 1. Our slope is 1/5, and x minus 10. So we distribute the 1/5 through, and 1/5 times -10 gives us -2. Subtract 1 from both sides, and we get 1/5 x minus 3. Now I wanted to include this because I did talk about it specifically, and that's an accident. That's not supposed to be there, but I just copied it. So here it says that we are going to complete an algebraic proof, and we haven't discussed this before, but I'm going to tell you a couple things about a proof. A proof will give you a statement. You have to have something to start with, and that statement will go in that first box there. Then it's going to tell you what you want to prove. Here we're trying to prove that x is 4, and so that will be that last statement there, and that's our end goal. We want to be able to prove that that's our answer. And so this proof is just telling you that here we have what's called a 2-column proof with statements and reasons, and we are going to write the reasons in these boxes of what allows us to go from step to step. So as I look at the first one, what allows me to go from this step to this step here? Well, it looks like they got rid of the 5, and how would you get rid of a 5? You would have to subtract it to the other side. So if I subtract it here, that's where that 16 comes from. So my reason is that we did a subtraction. If we were being very formal, we would say it's because of the subtraction property of equality. Now we want to see what happens from that step to the next step. So to get x all by itself, we have to pick off that 4. To pick off that 4, you have to divide by 4, and that gives us that last step. So we say that this was a division. You could say by 4. If you're really formal, you would say it's the division property of equality. So hopefully that'll give you kind of a heads up on how to do 19 through 22. And that's your assignment, 9-3 equations of lines. Good luck.